Coach, you're muted.
Okay, let me restart here. Well, welcome to 2020 FlySet FTC workshop. This is our 6th annual workshop. This year, as everyone have done, we have gone virtual now. Melody, can you bring up the next one? So far, based on registration, we had 132 people registered from over 52 FTC teams. We have roughly 30% of coaches and 65% of team members, and 20%, roughly 20% of rookie members, which is similar as our past summer's composition of attendees. This workshop, after established for 5 or 6 years, has become a place the teams sharing their ideas, knowledge about FTC technologies. So this year, because it's virtual, we are able to add more exciting topics here. We have invited industry speakers and also college speakers to give us the talk on the robotics beyond high school. So most of the attendees here are high school students, but now we have in the industry speaker and the college speakers to talk about what's beyond the high school. And we have 4 Cathy Bank grants to be given out, and Cathy Bank, Ms. Jenny Gong will be here to present that the grants, and Dr. Patrick Michaud will talk about the planning for North Texas region, which is very special, different than before because of COVID-19. That will be all of our guest speaker sessions in the morning. Then we will break out to 2 tracks in the morning. One panel discussion. 4 coaches will be panelists, talk about how to, the ideas they have planned in mind about remote coaching, training, tournament, and then welcome all the other participate in the discussions. In the parallel, we have a CAD, talk about the introduction of Fusion and some demo of the models. Then in the afternoon, we start with the topic about how the local teams helped in the last few months on the communities under COVID-19. We split into advanced and the beginner tracks, but we did plan a hardware. The hardware software are split separate, different order. So if you are a builder or your program, you are still be able to attend both sides. And throughout the day, we have a lot of giveaway drawings, thanks to the products provided by GoBuilder, Silver City, and AndyMark. And at the very end, we have we do have a workshop response survey. We welcome everyone's feedback for us to improve for future. So we have a final drawing on some used monitors donated by local companies. So with that all said, we can start. So Melody, you can start the workshop.
So now we're gonna have our first industry speaker, which is Dr. Sam Chen. Dr. Sam Chen works in helping corporations with China-US cross-border business. He has 15 years of engineering and managerial experience in robotics, software development, IT, logistics, and industrial automation. Currently, he works at Tompkins Robotics as an IT development director, where he manages the development of mobile robotic sortation software systems.
Thank you, Melody, for the very kind introduction. I think first thing I'm going to do here is to share my screen, correct? Let me see here. So, all right. Good morning, everyone. Thanks for being here. It's my pleasure to be doing this presentation. Today, I'm going to focus primarily on the logistic robots, specifically the sortation robots, which I have been working on for the last 2 years. A brief background of my education and the work experience. I got my PhD in mechanical engineering from Notre Dame with the focus in industrial robotics. I got my undergraduate degree from Tsinghua University in automotive engineering, and I've spent the last 15 years working for various companies in material handling, robotics, and software. Okay, so this is a graph I drew about 15 years ago, because I thought that was the direction our human society is going to go in. So I want to do a very brief survey of robotics. By physical structure, we divide the robots into robotic arms, which you can see the orange ones, the legged robots, robots that walk on legs, the wheeled robots, robots that move on wheels, and the Android robots. By applications, there are, of course, a lot of robots working in manufacturing, distribution, agriculture. Now more and more of them work in service, and then followed by military and police functions, and some robots work in entertainment. There's a wide variety of technologies behind modern robotics, such as mechanical dexterity, and such as which is illustrated by this mechanical hand, very similar to human hand. And then there's machine vision, there's machine learning, which here is a graph of neural network. And then there's another technology for mobile robots called localization and mapping, okay? So, and those are the locations around the world where the robotics firms are very dense at. And now I'm going to touch on today's specific topic, logistic robots. By the way, I don't really know, for example, the background of everyone at the meeting today and where your interests are, but feel free to raise your hand and sharing your questions in the background. I'll be happy to address all the questions, okay? But going back to logistic robots, I want to talk about the background a little bit. In the US, we used to have the largest manufacturing sector, and it's been moving offshore, okay? So manufacturing is going away. However, logistics stays because all the goods we consume have to be transported from where they're manufactured to where they consumed. Therefore, logistics, distribution, material handling, they stay in the US, they stay close to us, and they have been growing tremendously. And another trend we see in the last 20, 30 years is the rise of e-commerce. We have $25 trillion every year spent in retail. In the US, the number is about $5 trillion. And 10% of that $5 trillion in the US retail has been purchased on e-commerce platform. And in Asia, the number is even higher, is 20%. So why am I talking about this trend? Because it directly impacts where the robotic applications are going to go. The biggest demand for robotics is in distribution, is in warehousing. So the latest robots we see the most, that make the most money for the companies are oftentimes in the logistic chains and warehouses. Okay, and here's are some numbers, very interesting numbers comparing China and the US, and particularly Amazon's market share in the world and in the US. Amazon is the leading provider of e-commerce goods. So now I'm gonna show you the sorting robot I've been working on for the last 2 years. Let me see. The company I work for is called Tompkins Robotics. It's a US company based out of Orlando, Florida. And their Chinese partner is called LabZ, which is based in Hangzhou, China. And there's a reason why those two companies work together, because the US market and the Chinese market, they are the two biggest market for such robotic technologies. So I'm gonna, let me see here. Let me share with you a different screen here. New share. Let's see. Okay, here we go. All right. So, first video I want to show you is
as a variety of accumulation.
Is what traditional. Sorry, I'm gonna mute this. Is what traditional warehousing is like for sortation. Okay, you have like hundreds of thousands of packages every day in a typical warehouse, and they have to be sorted on a conveyor. And if you see the light blinking here, that's probably a scanner scanning the barcode attached to every tote, every box, every piece of product. Okay, so think of it, it's like the operations in a baggage handling facility at the airport. Okay, so this does not meet the e-commerce demand because e-commerce has literally made the volume of the processed goods probably 10 times higher as it used to be. Therefore, actually, this kind of robots, we call it the mobile sortation platform. Those robots, they're individual. Each of them is like computerized robot. And you can put in thousands of them in one facility. And they are two-dimensional or even three-dimensional. Okay, so they move on a large platform. And they move at about 2 meters per second. And you see all those holes in the platform, those are destinations. Because all those packages or goods, they go to a certain destination or go to a certain customer. Therefore, the robots carries all the products from the, okay, I'm gonna pause here a little bit. So those products, they come through this inlet dumper. So they're all mixed. So this human operator takes them out and put them on each robot. The human operator doesn't have to do any sortation. All it does, all he does, all she does is to put all the products on each robot. The robot will come and pick it up and the robot will do the sortation. The robot knows where the product goes, okay? So, so this is really the powering the logistics of modern day e-commerce delivery. That's how we achieve 2-day delivery with Amazon or Walmart these days. So the version I just showed you is the Chinese version. When we brought the technology to the US, we had to adapt it to a different system. For example, all the destinations, they are in the bins or chutes on the outside of the field. Okay, let me see. So we did 2 changes. One change is to, okay, sorry, go. One change is to locate the destination on the outside edge rather than in the holes on the inside, okay? I see some chats. Okay, great. So that's one change because the US warehouses, they're built very differently. And another technique we introduced is, let me see if I can find it here. Oh, here we go. So see this robotic arm? It replaces the human operator you saw in the previous video. In China, they use human operators to pick the things from a box, from a dumpster, and put them on the robots. But here, we introduced the US technology, which is to use this autonomous robotic arm that's aided with vision to pick. So that's a huge step forward, okay? So these videos, you can watch the full thing later on your own, but I want to talk about the technical aspects of the system. Let me go back to the presentation, okay. So what are the benefits of using robots? First, robots, they are modular. So for example, if we put down 1,000 robots to process 10,000 orders per hour, next year, we have more volume, we have more customers. We can just put down more robots processing the same order. If we use traditional machinery such as conveyors, then you can't really connect more conveyors to them because they're not modular, they're not like robots. It's just the number of robots you have to get it right. So we have the scalability with mobile robots. And the next benefit is low downtime. It also has to do with the modular pattern of the robots. Let's say a robot breaks, its battery blows up, or one robot crashes and destroys itself. It's very easy to deal with. We just take out that robot, it doesn't affect the rest of the crowd, okay? With the traditional conveyor-based sortation system, it's linear. So it's thousands of portions or sectors of conveyors that are connected together. If one sector of the conveyor breaks down, the whole system cannot run. So there's a much higher requirement on the uptime of the conveyor system, but with the robots, we can tolerate the robots breaking down or any other issues. The flexibility is also brought about by the robots. Each robot is like an individual computer. It can do some thinking on its own. It can deal with different situations and figure out different strategies on the spot. It's less pre-programmed when compared to traditional technology. Therefore, we are achieving a lot of flexibility. The speed, actually the robots, in terms of the speed, it does not have a huge advantage over the traditional equipment. But it has less downtime. So overall, it's got good speed. And next thing I want to say is it's cheap. Because those robots, they can quickly become commodities. The cost can go from $10,000, it used to be $50,000 a pop for the robots, mobile robots. Now you can get them for a few $1,000s, and they can get standardized, and they can almost become a programming platform on their own. Therefore, you can buy them and plug and play. The last thing I want to say is they are safe. Because all the moving components in the system are just the mobile robots, and they're small, they're nimble. So if they run into you, they don't hurt you. Whereas in the past, the high-speed equipment, they are motorized by high-power motors, and they can really cause safety concerns. So those are a few clients we did half of them in the US, the other half in China. I hope you have heard that name. Walmart, Nordstrom, they are the big retailers in the US, and as well as Target. And JD, Alibaba, they're the biggest e-commerce platforms in China, and China Post is also a customer. And I know you guys are all curious engineers, so I'm going to talk about a little bit more in technical terms, okay? So maybe you get curious about this sort of mobile robots. You wonder, hey, how can I get into it? What do I need to learn? Okay, so a few technologies are involved in mobile robots. The top one is battery longevity. Okay, I think we use Toyota battery. I'm not quite sure at this moment. But mobile robots, they can charge themselves, but you don't want them to charge too often. So they have to have good batteries. Okay. Second thing is motion control. You don't hear about this term very often. But for mobile robots, for the robot to follow a particular path to achieve a high speed and accelerate and decelerate at just the right time, it has to have very good motion control. And the wireless communication is another aspect. We can't really use Wi-Fi or Bluetooth because industrial equipment needs to be very reliable, have very low latency in its communication. And of course, you need to learn about embedded systems. They're not typical PC boards on the robots. And then other things that have to do with materials, for example, anti-static materials. A lot of mobile robots, they tend to accumulate static on them. The static can destroy their circuitry. So we need to do something about that. And some of the more advanced terms are computer vision. You use a camera to identify where you're going, what's your environment, and if you're going to run into other robots. So that's where computer vision comes in. And there's another term called collaborative robotics. That means the robots, they are safe enough to work around people. Okay, traditionally robots, they are isolated, they are fenced up because they can hit you and they could sometimes hurt someone or kill someone. It happened in the robotic history. But the new collaborative robotics, they are safe. They look out for humans approaching them. If they feel like they've hit something or someone, they stop suddenly. So those are the different aspects of the technologies. And it really should be a big motivation for you guys to pursue a career in science and technology and engineering, in my opinion. Okay, of course we have challenges. We have traffic logjam. The robots, they just like the cars on an interstate. They can logjam together. Okay, there's a speed limit on how fast the robots can go, and also the robots, they can only carry products of certain geometry or size or weight, and things as such. And there's special scenarios such to handle. We call it error handling. What if a robot lost something on the platform? How are we going to trace it back? And how are we going to recover it? And how are we going to even know it? Those are the typical questions you're going to have to ask yourself as engineers, all right? So that's my end of my presentation. All the questions are welcome. I'm here to teach and help you guys learn. Okay, all right. I'm not sure if those questions are for me or for all the panelists.
Dr. Sam Chen,
Yes.
there's a question in Q&A. I think that's for you.
Okay, okay, I see it now.
Okay.
Okay, so most of our FTC team members seem to be familiar with the classic controls algorithm. Could Dr. Chen mention more on the motion control part to them? Sure. You guys really ask tough questions. Motion control is a highly special field in robotics. I'm more familiar with the robotic arm motion control, such as the arms you use in the car manufacturing plant. The motion control normally breaks down into, for example, the servo motors, the drives, and also something called the precision speed reducers. And that's how motion control is achieved on sort of classic robotic arms. On our mobile robots, actually it's a technology that has been invented by our partners in Hangzhou, China. And I don't really know how they make it happen, to be honest. I know about some of the other motion control stuff with the robotic arms, but with this particular type of robot, I think they're using a Linux-based board to do the control. Actually, they had to redesign the servo motor just for this particular kind of robot. In terms of the control, the motion control algorithm, whether it's PID or some more fancier algorithm, I wish I had the answer. That knowledge is kept in a very small circle. That's considered sort of a trade secret. So, all right. Do we have another question?
Okay, if you guys have any more questions, you guys can type them in the Q&A and Dr. Chen can answer them by typing back to you. So we're gonna have our next industry speaker. Thank you so much.
Thank you, Melody.
Is an application engineer at Siemens Digital Industry Software. Mohammed is part of the academic team helping to create relationships as well as providing resources for success in schools, universities, and other academic institutions. Mohammed graduated from the University of Texas at Dallas with an undergraduate degree in mechanical engineering as well as a graduate degree in systems engineering and management. So, Mohammed, you could go ahead and get started.
Thank you, Melody. Hi, everyone. I'm Mohammed. I work for Siemens, like Melody said. Today we'll be learning a little bit about Solid Edge. It is a CAD software designed by Siemens, which is who I work for. So a little bit about Solid Edge. Solid Edge is history-free modeling. Which is a little bit different from history-based modeling, where in history-based modeling, everything is dependent on the steps that are taken to create a model. In Solid Edge, it is considered history-free, so the features are not dependent on the order. Let's say if we make a part file, a model, you know, a car, for example, and it has 100 different parts and features. And let's say you get to 100 feature and you need to go back and change feature number 2. Well, what you're gonna have to do is roll all the way back to feature number 2, make change, and hope that the rest of the features that are dependent on that change don't, you know, go get an error. So that is what it is for, you know, when you have large parts, when you have large assemblies, that is what it is used for. So Solid Edge is a history-free modeling where the changes that you make, all the features that you make a model are not dependent on how you know, what steps that you take. And you can also change the order if you so desire, because designing is not a fixed process that you go through. You know, you could be making a car and you could design it, you know, 100 different ways. So the order that you make it should not be a limiting factor. And this is best used for making modifications or working with a large assembly. When you're working in the industry, majority of the time, you're working with a part file or model that you did not make, someone else made, or that was previously made by the company, you know, a couple of years ago. So whenever you're trying to make modifications, you don't know what the other person made, the other designer, what they used, you know, what changes they made, how they made them. So this is really useful for that. And especially for working with large assemblies, which I will show you in a second an example of. And obviously it's easier to work with than a history-based modeling, because history-based modeling is very delicate, you know. The steps that you take to make a model are, you know, the model is dependent on that order. And if you don't follow that order, or if you change that order, the model will break down. But in history-free modeling, you have flexibility. You can make changes whenever you want, at the beginning of the design process, in the middle, or even after you're done with the design. Now, one good, really cool feature about Solid Edge is the synchronous technology, which you see on the right-hand side. Let me go ahead. So this is the steering wheel. A steering wheel you can use by clicking different parts of the steering wheel. You can make different, you know, modifications without having to even go into commands or, you know, features. So for example, in the arrow part of the steering wheel, if you click on that, you could make modification by pulling or pushing into the model, or translating it or moving it. Now, if you click on the round part of the steering wheel, you can revolve it depending on the situation. So it provides for, you know, you don't for easier and faster editing and modifications, which you will see in a second. And the best thing about this is when you're making modifications in Solid Edge, there's no need to go back to the sketch. Let's say, you know, you go from a sketch, you know, and you turn into from a 2D into a 3D, now it's a solid model. Now you don't even have to go back to the sketch. You don't worry about it. You can go back if you want to, but you don't have to worry about it. You're making direct changes to the solid model itself. In fact, you can even go ahead and delete the sketch, and it's not going to make a difference at all, which you'll see in a second. So this is the UI, the user interface for Solid Edge. And so what we're going to do, and you'll notice it kind of looks like a Microsoft Office product, you know, where you have the tabs and different commands. So simply go ahead and create a rectangle. And when you click inside of this, you will see the arrow that pops up, and you can immediately start extruding. You know, you can push in, pull, go in one direction, go in both directions. You can even move the steering wheel to the side, and you can revolve automatically just like that. So for this one, let's go ahead and extrude on symmetrically about the plane. Now you'll notice how the dimensions from the sketch directly migrate onto the solid model itself, and you can make changes to the dimensions directly, like we're doing right here. And you can even make modifications to the model itself without even having to go into commands. Now you'll notice there's a little design intent panel on the top right hand side, and that is for because we created the sketch symmetric to the coordinate system right in the middle, it automatically detects a relationship that there's a symmetry. If we don't want that, we can uncheck it from that little panel, but we can make modifications just like that. Now, I was talking about this where you can go ahead and delete the sketch as well. So the solid model will not be dependent on the sketch at all. If you were to do that in other software, you would have a problem and you'll have a whole bunch of errors. Now, what we're going to do is create a little line, a little region, and we can push in and pull out immediately. So we didn't click any command whatsoever, and we just did directly from the model. For this, let's say we want the vertical section and rotate it about 15 degrees a little bit. Well, if we were to do it in a history basis, we would have to go back to the sketch, change the sketch, and then roll it back. Well, in this, we can make direct modifications by selecting and moving the steering wheel to the axis, and we can immediately start rotating. We can even make it longer if we wanted to. We can move it to the side. We can make changes right there and then. So that's just some of the cool features and an example of how you can use Solid Edge. Now this is an example of a pulley assembly. Now this example we're going to show you is how to make modifications immediately just by one click. Now there are a lot of features, a lot of parts. We have to make modifications. How do you do it in a large assembly? Well, by selecting a few specific features and using the steering wheel, we can immediately make the pulley wider if we wanted to, instead of having to individually make the holes, the rounds, the fillets, all of those changes immediately. Now you'll notice once we made the pulley wider, it's not fitting into the assembly. Well, what do? Well, should we make it wider individually? Well, no. This is Solid Edge, so we're going to do the same thing. We're going to use the steering wheel by selecting a few specific faces. We're going to make the entire assembly wider. So we select a few specific phases that are going to dictate how wide the assembly is. And then using the steering wheel, with just one click, we can make the entire pulley assembly, the holder, wider by 10 millimeters. And then we bring the pulley back in and we can see immediately that it's a good fit. So just making a few modifications does not require changing all individual parts or components. On this one, we're going to make the spacer, the belt guard, match with the top one, and we can even make it wider just by selecting on it and using the command, the coplanar command. And just like that, we're able to make it longer without having to go back to the sketch or without having to individually make those changes. Well, what about if users are using CAD files and other softwares, what do we do? Well, Solid Edge allows you to bring in part files from SolidWorks, Fusion 360, Creo, and others. Because, and I mentioned this before, because Solid Edge is history-free modeling, we don't have to worry about how the parts were made. You can make direct changes to the model, and you can continue your progress where you left off from their other software. So let's say if you're using Fusion 360 and you want to try out Solid Edge and you want to use the part file that you made in Fusion 360, you can immediately bring that into Solid Edge, which I will show you in a second. So in this example, we're going to bring in a jaw gripper that was made in SolidWorks. And when you bring in a part file from other software, it does not contain any features, as you'll see on the left-hand side. It's considered dumb solid because it doesn't have feature. And it works for Solid Edge because Solid Edge doesn't care about the steps that were used to make the model. We're going to immediately start making changes just by placing a few dimensions and then making changes to those dimensions. We can start changing the model itself without having to worry about the sketch, without having to worry about the steps. So we'll make the little extension. We can make it one side or both sides. Now, another feature that Solid Edge has is the pattern recognition. It's a feature you'll notice because the teeth in the gripper have a red circular pattern. Well, we can use the pattern detection tool, pattern recognition, and it automatically detects there's a circular pattern, and it's saying that some of them are suppressed. So by pressing OK, we can automatically detect, and it will come into our pathfinder, our feature tree. And we can immediately make changes from 10 teeth to 12 teeth, just like that, without having to redesign or go back to the sketch. We'll do the same thing for the rectangular slots. Just by box selecting those, we can detect that there's a rectangular pattern, and we can make changes just like that. From 6 teeth, we can make it however much we want. Just like that. So without having to make any changes or modifications, we can easily do that now. Now this model right now is sitting on top of the coordinate system, and it's not symmetric to it. So if we were to pull the middle section, you can see right there that it's not symmetric. What if we wanted to make it symmetric? Well, we can easily change that by selecting the entire model using the quick pick. And we can take the steering wheel and put it into the midpoint of the model and match that to the coordinate system. And the midpoint will be exactly on the coordinate system. So now when we pull it, you'll notice the software automatically detects there's a symmetry. So it pulls on both directions. If you want to turn that off, you could just pressing S or using the design intent panel. So that's just an example of how you can bring in part files, part models from other software and immediately start making edits and changes and continue where you left off. Now, the best thing about Solid Edge is that it's completely free for students, for teachers, anyone in the academic field. And the license does not expire, so it's not a free trial. It's available for however long you want to use it. And we also have tutorials, guides, and videos available for you to use, as well as self-paced courses. We have multiple. We have what we call the Siemens Learning Center. We have multiple courses, from 2D, 3D, design, sheet metal, assemblies, all those. And then we also have tracks for people who are new to Solid Edge, who have prior experience, or people who are more experienced or advanced users. And finally, we also have the Solid Edge certification as well. Industry recognized 3-level of certification, which you can take and you can put on your resume. And when you go to the employer, they will recognize that you are certified in using the software. So let me go ahead and quickly show you the website, our Solid Edge resource site for students. I will go ahead and put the link in the chat after I'm done, so you can access it, and we have all the resources available for you right here on the page. So once you come here, you notice you can download the software for free. Just fill out a little bit of information, and then immediately the download starts. We also have learning material for you. On the Learning Center, this is a short video that walks you through how to register for the Learning Center. It's completely free, again, and you can use this to take self-paced courses. We have like Quick Start, 3D modeling. We even have a certification prep course. and as well as other courses as well. So some of these highlighted courses, sketching fundamentals that teach you 2D modeling, 2D shapes and patterns, 3D CAD, which walk you through 3D part modeling. And then this is a really interesting course, which I highly recommend. This is for generative design modeling course, which is the next phase of design, where right now the designer have to go in and create individual models. Well, the next phase is where the user can just put in the parameters, put in the requirements, and the software will immediately give out the best possible solution for that. So this is the next step in CAD design. So I highly recommend you check this one out, as well as other courses we have. We even have project tutorials, if you want to make birdhouse, rocket, front loader, as well as other tutorials. You can click on see more tutorials, and there's a bunch more tutorials available for you to use. And then you can get certified in Solid Edge, as well as other things, and then some of the showcases and links that we have. So that's about it from my end. If anyone has any questions, I am open to answering them.
I saw one person, Ravi, raise their hand. So I'm allowing you to talk now. You can go ahead and ask your question. So Ravi, you can go ahead and unmute yourself and ask your question.
Oh, sorry, I didn't have a question. I think I accidentally clicked it.
Okay, well, there is a question in the Q&A. There's two questions in the Q&A section. So the first one is, what advantages would you say Solid Edge has as compared to Fusion 360?
So that's a good question. Like I mentioned at the beginning, one immediate thing is that history-free modeling, where the steps that you take to make a model are not dependent on for creating that design. So Fusion 360 is a history-based modeling. You have to go step by step. You start with a sketch, then you build on top of the sketch, you go feature by feature by feature. And if you want to make changes, let's say at a feature, way in the beginning, you have to roll all the way back to the beginning, and then make that change and hope that all the features that came after are not changed or messed up. Well, in Solid Edge, you're not worried about what point in the design process you are. You could be in the beginning, you could be in the middle, you could be at the end. You can make changes whenever you want. You can move the order of the steps as well. And also, if you're using Fusion 360, if you were to, let's say if you made a solid model, and if you were to go ahead and delete the sketch, well, that would give you a problem. It would give you a bunch of errors. Well, in Solid Edge, we're not dependent on the sketch, so you can go ahead and delete that. So I would say Solid Edge gives you more flexibility in terms of designing, making changes, edits, especially in large assemblies and models where you have a whole bunch of part files or a whole bunch of parts or a whole bunch of features, as well as the steering wheel technology that is very useful. I highly recommend everyone to go check that out and try using it and see how they like it. Solid Edge is only, not sure about Linux, but I know it's not available in Mac. It's available in Windows. I'm not sure about Linux. FTC mentors use it for absolutely anyone related to the academic field. They're more than welcome to use it. Students, teachers, mentors. Even if you want to just try it out. I highly recommend you try out the software.
Okay, thank you so much, Mohammed. If anybody else has any more questions for him, you guys can go ahead and use the Q&A feature and he can go ahead and type your answer. So now we're gonna move on to our Cathay Bank grant.
Every journey has a starting point, a place where the story begins. Our journey started in 1962, opening our doors to serve the banking needs of an underserved community in Los Angeles. Today, we serve the needs of a growing number of communities with a vibrant network that extends from New York to Hong Kong. We've grown by being there for customers, communities, and employees along their journeys. We understand what it takes to move from hope to confidence, from opportunity to achievement, from ambition to success. Whether you're an immigrant navigating a new community, a young couple buying your first home for a growing family, a small business taking a giant step, or a new employee hoping to launch a career, we're there for every moment, every step of the way. We're always looking out for you. With hard work and heart, we can help you get wherever you want to go. When you're ready for what's next, start your journey with Cathay Bank.
So we're so happy to have Miss Jenny Gong, Cathay Bank DFW Area Branch Manager here today. On behalf of Cathay Bank, Jenny has been a regular supporter and sponsor of volunteer community services, especially on STEM and youth activities. So Miss Jenny Gong, you can go ahead and start.
Thank you. It's a great pleasure to be here at the FTC workshop today. Cathay Bank Foundation has been supporting our communities we serve in 9 different states. We're so proud to be able to support these robotic teams. During this changing and challenge situation, these teams still aim to hone their robotic technical skills to next level, outreach to younger generation, and offering YouTube tutorial. Great jobs. And now I'm so honored to announce the grant recipient teams. There are 4 teams. The first one is FTC team 1058, Nightmare from Dallas ISD. The second team is FTC team 14242, Black Star 4H Robotics from Fort Worth. The third team is FTC team 16412, Triad Robotics from Haltom City, Birdville ISD. The fourth team is FTC team 16554, Agents of SHIELD from Grapevine ISD. Teams, you will receive the grant letter immediately after the workshop, which has detailed instruction on how to reimburse your expenses. The grant disbursement process will be administered by ACP Robotics. Thank you all. Stay safe and healthy. Thank you.
Thank you, Ms. Jenny Gong. So now we're gonna have our first college robotics speaker. So Skylar is a computer science major student from Texas A&M University. He participated in VEX Robotics in the past and won 3 awards during the Asia Pacific competition in Hong Kong. He also worked as a research intern at both Shenzhen Technology University and Texas A&M University, specializing in blockchain technology and computer vision. As a Texas A&M RoboMaster team member, he is responsible for building the computer vision system for the robots.
Sorry, give me 1 second. Can you guys see my PowerPoint?
Yes.
Okay. All right. So my name is Skylar Zink. I'm in the TAMU RoboMaster Robotics team here at Texas A&M University. And this is a competition that is held at Shenzhen, China every single year. And it's an international competition. And before jumping into the details, I'm gonna show you guys a video of the rules of the competition.
Welcome to RoboMaster 2019. There are 5 different robots on each team: Hero, Standard, Engineer, Aerial, and Sentry. With each robot operating in first-person view, teams must begin from their starting zone, navigate a rune-filled battlefield, and find and launch projectiles at the opponent until they are eliminated. The robots are equipped with an armor system that detects projectile hit data, resulting in lowered health points when triggered. Robots are destroyed if their health points reach 0, but can regain health at the regeneration point. Playing a supportive role on the team, the engineer is capable of acquiring larger, more damaging projectiles from the resource island and passing those projectiles to the hero. The aerial is a subtle yet essential player of each team that can be incredibly advantageous when used wisely. It must be charged as much as possible before taking off. The aerial can fly overhead, offering a bird's eye view of the battlefield while firing on enemies below. As the only fully automated robot on the battlefield, the Sentry can detect enemies' defense capabilities and shoot them. If the Sentry is destroyed, then the team it belongs to loses its first line of defense. The team that destroys the enemy's base first is the winner. If the 7-minute limit of the match runs out and both teams still have their bases intact, the team with the highest total HP wins. Welcome to RoboMaster.
As you can see, this game is pretty interesting. It's basically League of Legends, but in reality. And these are the 3 robots of the top 3 universities from last year. This is the Hero robot. The Hero robot, they have bigger projectiles and they move around the field to hit the enemy robots. And as you can see, it's fairly complicated and we built almost everything by ourselves. For example, you can choose whatever CPU or GPU you want to use in this robot or any OS systems and also for my team, we actually kind of 3D print the gunner ourselves and use the motors to shoot the bullets. And this is a closer view. And this one is the standard robot. This one is smaller than the Hero, but it moves faster and it shoots more frequent bullets, but with less damage. And this one is the Aerial. It goes into the air and then shoots enemies or the enemy base or outposts down below. And this is actually the most costly robot out of all the robots. And this one is the Sentry. This one is the only fully automatic robot in the entire team. It has to detect the enemy robots and then shoot the enemy robots and move around by itself to avoid the enemy bullets as well. As the video talked about, there are 5 different kinds of robots, but for this year, they actually added 2 things. The first one is the dart system, which you can launch it and then hit the enemy base or outpost. And then the radar system, because everything is first-person view. So with the radar system, you can know what's going on the entire map. Well, this is my part because I'm in the computer vision subteam. So I'm gonna talk more about what we did to increase the accuracy of detecting and shooting the enemy armor plates. This is what you see as a driver, and this is what you see in reality. Well, you can see the armor plates are actually really small. So if you want to aim at them manually, it's going to be extremely hard. And each time you can only take a certain amount of bullets. If you run out of bullets, you have to regain them, which is a waste of time. So in order to reduce that kind of stuff, we have to increase the accuracy. So we need to hit the armor plates with most bullets as possible. So how do we do that? We need to first we need to detect the armor plates. As you can see, the armor plates is comprised of two bright blue lines with a number in between. Some teams actually use pure OpenCV to detect the armor plates. This one is computationally cheap because it doesn't use machine learning models or anything, but it doesn't really cover the edge cases, which it might cause inaccuracy. So for my team, we actually used a machine learning model called YOLO V3, which we train it with thousands of armor plates images. And so the robot can detect the enemy armor plates. And this is the video of the result of the detection result of my team. As you can see, it's pretty consistent and accurate. Sometimes, for example, this one, the confidence level is almost 100%, and this one's 95%. And this one is 80% because a part of it is kind of hidden. So now I'm gonna talk more about YOLO V3 because I know most of you guys are high schoolers. So you guys might find this topic interesting. If you see the diagram here, it's actually pretty complicated, but don't worry, I'll go through each step one by one. Hopefully you guys can have a better understanding of it. The first thing first, we need to know what the input image is. So a video is comprised of a lot of frames, which are images. And each image has a lot of pixels, and each pixel has 3 colors. And the first thing we need to know is the convolution layer. As we know, YOLO V3 is mainly built up by using convolutional neural networks. So basically, we have a filter. As you can see, the yellow 3x3 filter here. We kind of parse through the image, and then we get the convolved feature out of it. The reason for this is because we want to use the filter to filter out the useless information. We want only the high-level features. For example, this is the photo of a cat, but there's information we don't need. For example, the shades on the wall or stuff like that. And after applying the filters, the image becomes relatively black and white, which are the high-level features of a cat. It actually makes the computer to detect it more easily. The second thing we need to know is padding. The problem with the thing we talked about here is if the image is 5x5, after applying the filters, it will become 3x3. We lost information, but we don't want that to happen because that might decrease the accuracy. So there are actually different kinds of padding methods, but the one I'm showing here is you just create some extra pixels around the image. So when the filter parse through the image, the resulting image will have the same amount of pixels as the original image. So we won't lose information. And right here is the pooling layer. The pooling layer also uses a filter, but it's similar to the convolution layer, but the purpose is different. For example, if you have a 4K video, 60 frames per second, maybe, if you want to process information just like that to the computer, it's gonna be really slow because that's a huge amount of pixels. That's why we use pooling here. For example, if you have a 4x4 image here, if we use max pooling, we look at 4 pixels at a time, and we find the max value, and then make that the resulting pixel. So we're basically decreasing the spatial size of the original image. Or we can use average pooling. We find the average value of 4 pixels. So there are different kinds of pooling methods, but the whole idea is to decrease the spatial size, because sometimes we don't really need every single pixel. If we use every single pixel, it might increase the accuracy, but it's not really worth it because that's just too much computation power. And the last one is the easiest one. This is a fully connected layer, which is artificial neural network, actually. Because after getting all the high-level features and stuff like that, it doesn't really tell you if it's an armor plate or not an armor plate. So after getting the information, we have to connect it to nodes layer by layer until we have 2 nodes, which tell us, yes, it is an armor plate, or no, it's not an armor plate. So all the nodes have weights and biases. Once it goes through all the nodes, it's gonna tell you if the result is yes or no, yes it is, or no. If the result is indeed correct or it's not correct, it's gonna back propagate and change the value of the weights and biases. So next time, when we use another image, it can tell us the correct result. And that was about the detection part, but detection was actually the easiest part because we can just use a machine learning model online and train it with images we find. But there are more problems, which is aiming and prediction. Well, as you can see, when robots shoot out bullets, they don't go in a straight line because of gravity. It kind of goes, the trajectory is parabolic. And this is the first person view. And also, the enemy robot might be moving. So we need to know the speed of it, the acceleration of it. So we can shoot it ahead. And also our own robot might be moving, or the gunner might be moving. So the gunner might rotate and the camera might rotate. And also we need to know the distance between you and the enemy robot, because it takes time for the bullet to actually reaches the enemy robot. There are a lot of things to consider about. So, well, theoretically, we can just write physics equations and parse through all the information that we gather. But in reality, there are just so many confounding variables we might encounter. So if we use fixed physics equations, if we miss once, we might miss for the rest of the games. So we can't do that. That's why we use a thing called Kalman filter. Kalman filter, well, I don't think I have time to get deep into it, but if you're interested, you can find it online. It's a very interesting concept, and this is a workflow of common filter and some personal notes I did. Basically, the whole system can help us to do the prediction and naming part. And if you master all the skills that I talked about above, or you have some even better ideas, you can dominate the game.
Cube, there you go. Have the cube. Take the cube. Wow, that is what a passive aggressive couple of engineers. That's there. Impressive right there. Another red robot offline. He actually look at how they're not trying to get surrounded, but Blue 4 trying to get up the bunker. Looks like the NG was trying to get the trap there. Red 4 offline, Red 3 offline. They are just decimating them. They push it fast. Look at that sentry. Oh man. Wow. That sentry's half dead already. That's amazing right there. They're nearly wiping that team. Sentry's down. This is open. This is a stomp. Somebody said there was a tsunami warring, but here it is right here. It looks like a quadra kill. They just got the quadra kill. That is incredible. Absolutely incredible. Pentakill. There it is. Wow. That is our first pentakill of the entire RoboMaster. Yeah. This is awesome. They wiped the other team almost. Actually.
And there's another
cube. There you go. Cube. Almost down. That's going to be really bad for Evolution. Where is Zhao's drone? Oh, wow. Yeah. 2 minutes, 30 seconds remaining. Why have they not put their drone in the area? Oh, the double kill. Very nice. Red 1 just got 2 kills there. Oh man, that melt though, look at that. All of a sudden, that double damage, it is all over. 20 damage per 17 millimeter. The rate of fire is triple kill. Triple kill, look at that. They're not, why aren't they finishing it? Practice. There we go. Right, look at that. Maybe they ran out of ammo? Maybe so. I don't know. They've got 200 left on there, but I think there's no way that they're going to be able to come back from that. Yeah, the drone's up. I don't think there's another pentakill. How are we getting so many pentakills today? We haven't had them at all. That's 2 in a row. The Zhao Dragons breathing fire on Evolution. Nice, Krylani. Almost.
And that's everything I have for you guys today. I think it's time for answering any question you guys have.
There's a question in the chat for you.
Okay.
I can go ahead and read it out.
What is the question? What's your budget?
No, I can read the question.
Okay, please do that.
In this YOLO V3 model training procedure, is there any overfitting problem that it only works on a certain narrowly selected samples well?
That's a really good question. That's why you have to choose the good images to train the model. You have to get a lot of different videos and try to get different situations. Well, basically, the result of the machine learning model is based on the quality of the data. So there's a saying that's called garbage in, garbage out. So you have to find good data in order to get good result.
There's another question. What's your budget?
Okay. Well, it's actually really expensive. For the robots are actually really expensive. I'm not entirely sure, but I think the aerial would be thousands of dollars or close to $10,000. I mean, it's at least thousands of dollars. And it's also based on how much you're willing to invest in. If you have the money, you can buy 2080 Ti as your graphic card, or you can use carbon fiber as your like chassis or something like that. So it can be cheap or it can be expensive. Yeah.
Okay, thank you so much, Skylar. If anybody else has questions for him, you guys can use the Q&A feature and he can type the answers out. So now we're gonna have our next college speaker. So Kevin Robb is a senior at the University of Oklahoma, double majoring in engineering, physics, and math with a minor in computer science. At OU, he has participated in Suitor Competitive Robotics, Hacklahoma, and the Robotics Evolution, Adaptation, and Learning Laboratory. During high school, Kevin was the captain of FTC Team 6566 Circuit Breakers and led the team to the World Championships. So you can go ahead and start.
Let me get my screen. All right, can you guys see it?
Yes.
Awesome. So, yeah, I just put a nice picture on here of my robot from when I did FTC in high school. This was the one we took to the World Championship, and then next to it is a robot that I made my sophomore year of college in the Mercury Remote Robot Challenge, which takes place at Oklahoma State University each year. So some main differences I just want to point out right at the beginning is kind of the big thing about FTC is you learn a lot of skills and you really apply those skills by taking pieces from like kind of a kit. So we made a lot of stuff on our own by cutting like plexiglass and proto board and all kinds of stuff like this. But ultimately we had the pieces, we had kind of a set of electronics and all this that we used together to build the robot that you see here. But then with college robotics, you start from scratch. So we had to decide what motors we wanted, what motor controllers we wanted, if we wanted to use an Arduino or a Raspberry Pi, or kind of what we wanted for the main electronic system. We 3D printed all the parts, ordered our own motors, or wheels rather, and designed all kinds of mechanisms and things like that. So really, and I'll get into this a bit more in a few minutes, but it gets a lot more complicated, and you can really do a lot more specific towards whatever field you want to get into. A little bit about me. I think most of this was already covered. Yeah. And we did a fun photo shoot of all the robots that I've worked on through my time in college on the ground with me right here. It's pretty fun. Let's see. So in terms of opportunities at college, there's kind of 3 different areas I want to mention. There are those competitive robotics teams, which is kind of like the RoboMaster challenge that Skylar just talked about. And this also includes senior competitive robotics that I'm going to be talking about. This would be, building a robot throughout the course of the year and then taking it and competing against other universities. And then there's hobbyist robotics clubs, which at OU we have a club called OU Robotics Club, and they use the same lab as senior competitive robotics. They just build random projects and basically just hang out, work on robots. And so if you really like kind of that aspect of it, not as much the strategy and the competition and all that, then a lot of universities would have these. So I would say, try and look for those once you get into university, because it's going to be a good community and a good way to learn a lot of good skills while just kind of chilling. And then lastly is robotics research. And this is the real lab that I've been working in, which is the Robotics Evolution, Adaptation, and Learning Lab. And research really kind of varies wildly. So at OU, we have the real lab, which focuses on risk, nurturing, reinforcement learning, machine learning, like artificial intelligence, like kind of that whole area. And then in the aerospace and mechanical engineering department, they have a mechatronics lab, there's a drone lab, all kinds of stuff like that. So there are lots of different areas for robotics research. So once you get into your major, you can kind of look around at whatever university you attend, ask professors who are doing research and try to get into that. And I would highly recommend getting into that even if you're already on one of the other 2 main types of robotics organizations. And this is going to be something that'll teach you a lot and that you can really kind of lead into graduate school and a career or whatever you would choose to do after that. All right, a lot of text here. Let's see. So another thing different from kind of the high school scene is, at least at my high school, we did FTC and we didn't have any other competitions, which meant whatever the FTC competition was that year, that's what we went to. In college, there are a lot of different competitions, and we as the students have complete say in what we compete in. So some schools are legacy schools. They like to compete in the same competition every year for a long time, and they get really good at it. At OU, we like to kind of keep it fresh, so we change out our competitions we attend pretty much every single year. We We always go to Mercury. That's kind of a good mid-level competition that people can, like beginners can work on, and veteran members of the team can also have a great time on. But we've also attended the IEEE competition, and this is the, I don't remember what it stands for, something for electronics and electrical engineers, and it's a very electrical heavy and software heavy challenge. And we only recently stopped going to that one. IGVC, the second one, is the team I'm the captain of currently. This is the Intelligent Ground Vehicle competition. So this is a much larger robot than the one that you saw in the original picture on the first slide. And this is a super software heavy, mechanical heavy, electrical heavy challenge. It kind of focuses on all three of our main sub areas. And it's kind of a navigation based challenge. So my primary academic interest is in autonomous navigation. So this is like perfect for me. A lot of other people in the team are also trying to go to graduate school for this kind of thing. So this gives us a great chance to really explore that. And there's going to be some more about that on a later slide. SumoBot was a really simple competition that I was a part of my freshman year. Basically built a little sumo robot, and there'd be two robots in a little ring, and they would have to autonomously try and push the other robot out. So very simple, but there were some really cool aspects of the software design and kind of how we wanted the state machine to work. And then there's also some good mechanical elements for making sure that your robot would be able to win in like a head-to-head standoff. Mercury Remote Robot Challenge is very cool. This is a teleoperated challenge where the robot goes through an obstacle course, and it's controlled from at least 50 miles away. So we stay, or we have half the team stay in the bench lab at OU, and the other half of the team takes the robot to Oklahoma State University for the competition. And so we have a little camera on it. We have sonar sensors on the sides. We have light sensors on the bottom. And all of this kind of helps the drivers back home to be able to tell what's happening with the robot. And this is kind of to simulate like a search and rescue type mission where you might be as far away as on a different planet, like Mercury, hence the name of the competition. And then these last two, not too different. So Robo Magellan, very similar to IGVC. It's autonomous, GPS based, and there's a lot of computer vision involved. And then NRC is kind of a race. So there's like a set of cones in a parking lot, and the robot has to autonomously race around the cones as fast as possible, going through loops and jumping over ramps without like going out of bounds or like running into anyone or anything like that. All right. Next big thing is that projects are a lot more modular. So in FTC, I was the team captain, and I basically knew what was going on with every part of the robot. So I could work on the software one day, I could work on building the robot the next day, I could work on the wiring the next day. That is not what I do in college anymore. So now I am on the software sub-teams. So I work on stuff like the navigation, the localization, computer vision, all kinds of like that specific software type stuff. And then even within the software team, it's kind of specific. So there are some things that I don't work on, including like the firmware, so the code that makes my control commands actually be understood by the microcontrollers and the motors and make the robot actually do things. That's not my area, so I don't do any of that. And we use something called Robot Operating System, which is a really cool publisher subscriber type thing, where you have a bunch of different software files that are all running simultaneously, and they're all publishing and subscribing to different information. So for example, like the robot has an IMU on it, which publishes some useful information for localization. There's also odometry and that kind of thing. So that runs, publishes that information. My localization node subscribes to that information, uses it to figure out in global coordinates where the robot is, what its local heading is to its previous trajectory, and what its global heading is. And then it publishes that. And then my path planning node subscribes to that, uses that to come up with a path. You get it, it keeps going. And it doesn't have to be linear either. So it's a very good way to be able to work with a group of people on different software projects and all kind of have those modular goals. So yeah, and this is more like an actual job or research position. And you get a lot of really specific experience in whatever you want to do. And this might not be the norm with all college teams, you know, all across everywhere. I know it's a big country, there's a lot happening, but generally this has been my experience. And then I already mentioned we build robots totally from scratch. We don't use any of these standard kits. And then, it's college. We have a lot of people taking classes in very specific things. So people majoring in electrical and computer engineering are the ones doing the wiring. Mechanical engineering majors are the ones doing the SolidWorks and all the 3D printing, machining the parts, that kind of thing. And then, of course, the computer science and related majors are working on the other things. And we don't like restrict it by majors or anything. It's just usually people want to work on what they're going to be doing in grad school or wherever they're going next. And robotics is very interdisciplinary. We have like 9 different majors represented in SCR. So we have like chemical engineers who work on batteries. We have aerospace engineers who just want some more experience with SolidWorks and all that kind of thing. So it's a really good way to get to work with people with a lot of different backgrounds. All right, intelligent ground vehicle competition. So this is the competition that I'm the captain of, as I said. Fully autonomous driving robot. You can see a picture of it on the right here. And this was not our robot. Unfortunately, last year was the first year we participated in this competition. And so we all know how that went. Our competition was canceled and we were kicked out of the lab in March. So here's our robot, which was halfway done. And yeah, it autonomously must stay in the lanes, these little spray painted lines on the ground, and avoid all these cones. And there are different colors as well. And the score is based on your time. So this is our like expert competition. As I said, we use robot operating system. And so, as I said, this is very software heavy competition. We have a lot of sensors working together, and we actually use an extended Kalman filter, an EKF, which is something that Skylar mentioned in the previous presentation as well. I found that a really good tutorial for this is at kalmanfilter.net. So if you guys are interested, I would highly recommend checking it out. It's a super cool way to get tons of different sensor input, including like GPS waypoints, the computer vision, all of the different sensors, like basically anything that your robot is learning about the environment, you can kind of merge it all together and then it'll be able to figure out where it is. So this is super cool. Highly recommend checking it out. And then we have a hardware-based e-stop. So we had to make it so when you push the button on the remote e-stop, it physically cuts power to every part of the robot, which is pretty cool. All right. I'm not going to take too long on this one, but why do robotics in college in the first place? That's kind of the big question that I end up talking to a lot of people about. The ultimate reason is that it gives you a team to work together, learn together, and just have people to hang out with. So my primary friend group is the robotics team, just basically what it was in high school too. But yeah, so it's just a really cool environment, you know. So you're learning stuff in your classes, but that's kind of, you know, a professor teaching you things. Whereas if you're on a robotics team, generally, you and your friends on the team are like, it would be really cool if we had a way to detect the lines better. And then you spend time researching. You learn a lot more than you would in your classes because you're doing it on your own. And you get to do it with your friends as well. So you get some really cool applicable skills. I know there's like a grad level class called Control Theory at OU. And basically by the time that we are juniors on the team, we have already learned all the stuff you would, not all the stuff, but some of the stuff you get in that class just by being on the robotics team and getting a lot of that done. So really cool stuff. Gives you great projects to talk about in like interviews, grad school apps, anything like that. I don't think I've talked about classes at all in interviews. I talk about my projects through SCR. I talk about stuff from Hacklahoma, which is OU's hackathon. I talk about my research projects, like all that kind of stuff. So it's going to be kind of the best way to get some really solid experience. And my opinion is that as an engineer, you want those projects on your resume. So having skills is great, but if you have a project where you can talk about specifically how you learned those skills or applied them, then that's going to be kind of the best way to go forward. A good way to feel out your engineering discipline. So I actually started out as computer engineering, didn't like it that much. So I switched to computer science, and then I was also a physics major. So I ended up combining those into engineering physics, and that's kind of how I got where I am. But yeah, you can try out other parts of the team. Just try out working physically with kinds of stuff to see if you like your current major, if you might want to change it, that kind of thing. Great starting point for a course-based or project-based master's degree, and it's fun and very cool. And I put some pictures around the sides of some of our robots. All right. And question, this is the last slide. So I put a link to SCR's website. So Senior Competitive Robotics is just ou.edu/SCR. We have lots of pictures, cool stuff about all our teams and all that kind of stuff. So if you're coming to OU, especially check us out and join. But you know, regardless of where you're going for college, there's probably going to be some kind of robotics team there. If you're interested in some of my projects, I put my personal website and my GitHub link, which is where all the code is for all the projects. And you can see a blast from the past. So this was a couple of FTC pictures as well, like when I wore the cape and crown. And then this is just me at the career fair last year. So that's my presentation. And if you have any questions, I would love to answer them.
I think there are a few questions in the Q&A section.
Alrighty. You say you're using ROS. Yeah. So we're using ROS. We have used this for a couple of years now, and it is pretty awesome. It's like basically the industry standard for robotics and things like this. And it is taught in the Intelligent Robotics course at OU. So some of us took the class, saw that we were using it in the class and said, this would be very useful for the team. So we started using it on the team, and then a lot of us used it at internships as well. So it's super cool. Definitely recommend it. We're using ROS 1. We are considering switching to ROS 2 now that it's kind of got a stable build out, but probably not going to happen this year, at least. And then why did you choose OU? So OU has a building called the Engineering Practice Facility, which is super sick. It's basically this whole building that has nothing but student life resources. It's got like a whole bay area with all the competition teams set up. And OU has a bunch of different competitions. So there's like the rover team, the rocket team, the racing team, and they all build stuff. Like the racing team builds a race car every year from scratch for competition. So there's all these teams. There's a machine shop, a lab, a tutoring area, like all kinds of great stuff. And then robotics labs in the basement. So whole building just for student resources. I came to OU, saw that, and I said, I want to do robotics as a club at least, maybe as a career. So kind of why I chose to go there. And what website brand do you source your materials from? So kind of all kinds of stuff. So generally, another aspect of robotics competitions that is not really in the spotlight is that you need money from somewhere. So we actually seek out corporate sponsorships and donations of materials. So we use a lot of filament, and we use a lot of like aluminum if we need metal pieces. And all of those get donated by companies who are our sponsors. And then in terms of software, we are sponsored by SolidWorks. So we have licenses for that. It's a CAD software, kind of like Fusion 360. And then we use Altium Designer for designing PCBs, which is printed circuit boards. And they have sponsored us and given us a license. We're sponsored by a motor company that lets us pick any motors out of their stock to send us each year if we want. So basically, we seek out companies and they send us stuff. But generally, if we need anything that we don't have a sponsor for, we just look on Amazon, or we look on, what's it called? I think McMaster Car is a good website. So they just have tons of like screws and any parts you could need, as well as SolidWorks models of them. So generally, we just search the internet, find the cheapest thing we can, order it, slap it together, try and get it to work. All right, that is all the questions I see.
Okay, thank you so much, Kevin. If you guys have any other questions, you guys can leave them in the Q&A, and Kevin can go ahead and type out your answer. So now we're going to have our next speaker, Dr. Patrick Michaud. As everyone knows, First in Texas took over the lead organization position for official First Tech Challenge events in the North Texas region this season. Dr. Patrick is the official partner representative of First in Texas for North Texas. He actually has been in the same role in the past few years too, while under UTD. Under his leadership, North Texas has seen the number of FTC teams grow from 120 to over 200, and from a few qualifiers to almost a dozen qualifiers each season plus league play. He is also the well-known coach of FTC Team 7172 Technical Difficulties, which has made it into the World Championships many times.
All right. Hello, everybody. Can you all hear me? I'm hoping you can hear me.
Yes.
Okay, good. I wasn't sure my microphone was going to work. Good morning, everybody. I'm glad so many people have been able to make it to the FlySet workshop. Again, these workshops go on every year, and they're always just really good start to the season and getting a lot of information out to teams. So if you don't know me, my name is Patrick Michaud. I am the partner representative for First Tech Challenge here in North Texas. And I have some slides here. Hopefully you all are able to see my slides okay. Somebody let me know if you're not. And so this is going to be just kind of an overview of things we know about the upcoming season. I know that lots and lots of people have tons of questions about what's going to happen because of the pandemic and all of the limitations on, excuse me, being able to bring people together for events. And I mean, how do you even meet for teams? So I'll cover as much of it as I can. Unfortunately, the answer I have for a lot of it is we don't know yet. We are waiting to make decisions because we don't want to make commitments too early that we may then turn around and regret. So let me just go through some of what the news is for First Tech Challenge in North Texas. As Melody said, First in Texas is now the partner representative or the partner organization for First Tech Challenge here in North Texas, and University of Texas at Dallas, because of financial considerations, they decided they needed to close the department where I worked there. And they've also eliminated my position. So I have joined up with First in Texas instead to continue to bring First Tech Challenge to North Texas. For those of you who are also in First Lego League, then you know that First in Texas has also taken over First Lego League in North Texas, and Kelly Goodner is still the representative for that. So that's something that's kind of new for this year. The other thing I would like to tell everybody to be sure to do is to join the North Texas FTC Google group. The address is there on my slide, and that's where a lot of announcements of things happen, especially those things that are unofficial. When I try not to send too many messages directly to coaches, especially for things that are not official communications or not official events. And so I definitely recommend that people, go ahead and please join that Google group, because that's where a lot of unofficial things happen. That Google group is also where you can ask questions. So if you have a question about how to build a robot, you're having trouble meeting, you're having trouble doing things, then that is a place that you can go to do that. This season that's coming up is called Ultimate Goal. I'm hoping it'll be an exciting game. The whole theme for the updated season is game changers. So all of the first programs have games that are around sports and games and things like that. I have seen the upcoming game, a sneak preview that they give to the representatives, but I can't give you any details about it. So that's all I have to say about that. The calendar that we're looking at for the upcoming season, because of the pandemic, because of all of the limitations on gatherings, everything is just being pushed back. This is true throughout the state. It was what I was planning to do in North Texas. In North Texas, we're kind of fortunate, I guess, in that it wasn't all that long ago that we had a season that basically took place in January and February. And so we will be continuing that or going back to that for this season. So we know that we won't have any official competition events before November. That would be the absolute earliest. And we won't have any what are called in-person or traditional events before the first of the year. I'll talk more about those events here in just a little bit. There will still be a kickoff, and the kickoff is set for September 12th. Unlike past years, we won't be having an in-person kickoff. So what I'm thinking of doing this year, and I'm open for suggestions, is to have teams be able to watch the official first kickoff online that will take place at 11 o'clock on September 12th. And then a couple of hours after that, we're going to open up a webinar where we'll have a field set up with a couple of commentators who can go around and let you actually see the field through the webinar, and we'll be able to take questions and to talk through different things, because I know that just viewing the video is not always give you the same sense of having the field as being able to walk on it or see it up close or ask questions about it. That's why we've done the in-person kickoffs for the last couple of years. So on September 12th, we'll have a Q&A session where that'll give teams time to watch the video, to download and print the rules if they want, to read them through once or twice, and then we'll just open it up and do a Q&A session like we've done in past seasons. We'll probably reprise that again later in the week as well, as people have more questions and things like that. In September through November, we will continue to have various workshops and clinics. I've been doing a weekly chat clinic on Thursday nights, and if you're subscribed to the Google group, you get the announcements of when those are taking place. It's wide open for topics to be discussed in those, and so that will happen. From late October through December, one thing I am excited about this year is the possibility of doing remote scrimmages. Many of you who've known me in FIRST for a long time, I'm such a big advocate of scrimmages. I think that makes a huge difference to the success of teams in the area. And so since we can't really easily do in-person scrimmages, we could do some unofficial ones if health restrictions release enough. But we can certainly do remote scrimmages using the remote event format that FIRST is putting together that I'll describe in a bit. I expect most of the qualifying tournaments and league play to take place in January and February of this upcoming season. And this year, again, we're pushing things back. So the regional championship will be probably in mid-March, as opposed to being in February as it has been in years past. So just things will be a bit later. I also believe that by moving our tournaments to being after the first of the year, that gives teams more time to work on their robots during the fall, because I know it will be difficult for teams to gather and be able to work on their robots as they're doing things. So let's talk briefly about traditional versus remote events. And those are the official FIRST terms that I'll be using throughout the season. So we're not calling them virtual events. We're not calling them, online events. We're calling them remote events because they are still events and they count, and you can advance from them to higher levels of play. So we'll start with traditional events. For those of you who are rookies, first of all, welcome. But traditional events are described in Game Manual Part 1, and traditional events for the upcoming season will be very similar to what they've been in previous seasons. So in a traditional event, you'll have a group of teams that will gather together and matches take place. When the matches take place, there are 4 robots on the field at the same time. 2 robots form what's called the Red Alliance, and they're playing against the 2 blue robots that form the Blue Alliance. You go through and play a set of matches called qualifying matches. At the end of those qualifying matches, you get a rankings. The top ranked teams will then pick partners for alliance selection, and you go into playoffs and then do awards. That's going to be much the same for the upcoming season. If we are still under health restrictions when we get around to doing traditional events, and assuming we're able to do them at all, which I'm very hopeful that we will, we may do reduced attendance. So we may say we're having a traditional event, but only the drive teams and coaches should attend to reduce the number of people that are there. When we do that, we will live stream the events. We have equipment that we have accumulated over the last couple of years to be able to live stream events. We will make sure that we find ways or invest to be able to live stream the events so that everybody can see what is happening. In those events, we may also do remote judging. That is to do the judging by a Zoom call or some sort of online conferencing system, possibly in advance of the event or in advance of the day of the matches, just to be able to get a traditional, competitive environment together. We're still waiting to see what the health officials tell us we can and can't do, and then we'll be making decisions about those. For remote events, this is brand new for the upcoming season in response to the pandemic. FIRST has been working on all of their different programs and competitions to come up with ways for teams to still build robots and compete, even if we can't gather. And so in a remote environment, there aren't alliances as we've had in the past. Teams will compete individually on a field. It will be using the official game elements, although there may be some options for building your own elements if you can't afford an official set. We're also exploring that we may have designated places where teams can go individually, one at a time, to conduct their matches. In a remote event, then the judging sessions do take place online. That's not an in-person gathering. So that's what we're looking at for remote events. FIRST has not released all of the details of how remote events will take place. They are still working on those. And so as we learn things, and as I learn things and I'm able to share them with you, I will certainly be doing that. There is no alliance selection or playoffs in a remote event. So at the end of the day, whichever teams have the highest rankings, those are the highest ranked teams and the ones that are considered for advancement. The events will all take place via an online remote event site that FIRST is developing, where it manages your match scheduling, it manages the reporting of scores, it manages a lot of the different features that would normally take place at an event site. And that has me somewhat excited because we can do that for scrimmaging. We should be able to set up remote scrimmages and conduct scrimmages over the course of several days, where teams can really get a chance to see what other robots are doing and to see how well their robot performs in the remote competition environment. For remote events, there's flexibility in scheduling. It doesn't all have to happen on one day. We can do judging over a series of days, like in the week before the official competition date. Same thing for the recording and playing of matches. They don't all have to happen on that Saturday. They can happen on designated days, or with some flexibility for teams who may have difficulties in scheduling or challenges in getting their schedules together. So our planning as of today, no competition events in calendar 2020. If local health restrictions get much better, we could change that, and we'll give teams plenty of announcement, but that's the current expectation. We will be planning to do remote scrimmages. Hopefully, we will be able to do mostly traditional events by January and February, but if that's not the case, we'll do remote. And even if we do all the traditional events, there may be some teams who are in a situation where they can't travel to an event, or they're restricted from being able to attend a traditional event. So I'm guessing we will almost certainly have one or two remote events in the upcoming season, even if the health restrictions are such that we're able to do a lot of traditional events. Other things to just be aware of for 2020, 2021, just things that you can find in Game Manual Part 1 but are easily overlooked. So first of all, the ranking system has changed for this year. So for those of you who have been in FTC for many years, or even just a couple of years, then you know that the way teams were ranked was based on the number of wins, the number of ties, and the number of losses that occurred during their qualifying matches. That no longer exists, and it doesn't exist in either traditional events or in remote events. So team rankings are based solely on your qualifying match scores. However many points you score in a match, that gets summed up at the end of qualification matches, and whoever has the highest total number of points scored in the qualification matches is ranked number 1, and whoever is next highest is ranked number 2. And there are facilities for doing tiebreakers if we need to tiebreak things based on how your robot scored those points. But that is the ranking system for the upcoming season. The next thing is that penalties are different. In previous years, penalties would cause your opponent's score to increase. In this season, penalties will cause your own score to decrease. So it is now a direct penalty directly affects your own score. It does not affect your opponent's score. And part of the reason for that is because if you are competing in a remote event and you are the only robot on the field and you commit a penalty, there's not an opponent to award penalty points to. So now penalty points reduce your own score. So that's different for the upcoming season. The advancement criteria has changed. The control award, which was at the very bottom of the award advancement list for many, many years, ever since it was introduced, has now been moved up a bit in the advancement criteria. It now appears above the Motivate Award and the Design Award. So if you're familiar with the award advancement system for judged awards, it is now Innovate, then Think, then, I'm sorry, not innovate, inspire, then think, then connect, then innovate, then control, then motivate, then design. So that's a change, and I think that that change will mean a lot more teams will apply for and try to receive the control award than has typically happened in previous seasons. So I kind of like that particular change. The engineering notebook. I also expect there to be changes in the engineering notebook. And you can kind of see this if you look in Game Manual Part 1, the one that was released back in July, because all references to the term engineering notebook are now gone. They do reference engineering documentation. So for those teams that are used to doing engineering notebooks, I would encourage you to continue to do an engineering notebook. I think it will still be a part of the judging criteria, but just know that there are some expected changes coming in terms of what sorts of documentation you will provide for judges and the ways in which the engineering documentation will be done. So that's just another thing to look forward to. All right, and I think that is the end of my slides. I see that there's a question in the Q&A, so I'll just answer questions in the Q&A and however else may come in. So the question is from Justine Thomas asking if roboplex.org/FTC is still active. The short answer is yes, probably. I haven't been keeping it up to date because for the past 2 or 3 months, I've been in this transition period of not knowing who would be taking over FTC and who would be in charge, and also not even being able to schedule or list events. But based on things that have happened this past week and some discussions with First in Texas, we're expecting to keep roboplex.org alive. So that is a place you'll be able to go for official event announcements. And we will hopefully start keeping that up to date here in the next couple of weeks, and you can be looking for information there. For traditional events, another one from Maddie Stevens. For traditional events, will we be required to wear masks? The answer is for traditional events, we will follow whatever PPE guidelines and health guidelines are in place by local officials, state official, the CDC, and First in Texas. First in Texas has their board that is meeting. The First in Texas has actually put together a PPE team. And so assuming that mask restrictions are still in place when we get to traditional events, then yes, we will expect you to wear masks, and teams would be requested to bring their own masks, just like we currently request teams to bring safety goggles. It would be considered a piece of safety equipment. So any PPE requirements or any social distancing requirements that are in place at the time of traditional events, we will absolutely follow, because it's very important not only to keep ourselves safe, but keep all of those around us safe. Patricia Flores asks to list again the new order of awards. So it's in Game Manual Part 1 if you look in the advancement section, but just to go through the order of awards for advancement, it's Inspire 1, 2, and 3, and those are of course interleaved with the teams from the winning alliance if you're at a traditional event, or the top 3 teams if you're at a remote event. So the Inspire 1st, 2nd, and 3rd are the first ones to advance, followed by the Think Award winner, then the Finalist Alliance captain, the Connect Award winner, the Finalist Alliance first pick, the Innovate winner, the Finalist Alliance second pick, if there is one, and after Innovate would then be Control, Motivate, and Design. So again, the awards are Inspire, Think, Control, Innovate, Inspire, Think, Connect, Innovate, Control, Motivate, and then Design. So Design is now the lowest one on the list. And I'm a couple of minutes over, but if there are any other ones, so we have one here. At PISD schools, only UIL teams and groups are currently allowed to practice and rehearse. Does FTC have official UIL status? I'm not sure that I can answer that, but my guess is yes. First Tech Challenge has been an official UIL competition for the last couple of years. Certainly it was last season. That does continue into the upcoming season. And so it is an official UIL sport. And in order to, official UIL activity. And in order to be able to get to the UIL state championship, you would need to place well at your regional championship in First Tech Challenge. So as far as I know, if you are looking to claim that you're a UIL team and you're in First Tech Challenge and you're in Texas, then you should be able to make that claim. And I think that may be it. If there are any other questions, always feel free to email me or post them to the Q&A or bring them to one of our weekly chat sessions, and I will turn it over to whoever's next.
Thank you so much, Patrick. So now we're gonna have our giveaway, our first giveaway. So this is giveaway number 0, and we're going to be giving away 2 Andy Mark t-shirts and 1 Andy Mark plushie. So the way we're going to do this is we're going to take all of the registration numbers and put them into a wheel and then spin. And the winner has to be present for them to claim their prize. So if you win, please make sure to just notify me in the chat. You can use the all panelists feature, and then we will contact you with more information later. Okay. So the first winner of the Andy Mark t-shirt is 134. So that's Kyle Webb from 12167. So if Kyle is here, please let me know in the chat. Okay, so Kyle is here. So he'll have the first Andy Mark t-shirt and we'll contact you after the workshop. And then for our second Andy Mark t-shirt.
Yeah, I will look up for you. You will switch screen.
Okay. We have 113.
It's Shrima V from 7172. Okay, looks like she's not online. Let's just do another drawing. '66 is Samuel Flores from 15151. Samuel Flores from 15151 team. I guess not. Then we continue again. Okay, so 141, we don't know. It's pretty late, registered this morning. Gary Smith from 3 teams, 17304, 17306, 17307. I guess not. Let's continue. Uh, 115 is Ben Hoskin from 14145 team. If we, okay, I guess Gary is in the CAD track. Is the CAD track already started? Okay. So is what's that 115? 115 is a Ben Hoskin from team 14145. Okay, so let's don't delay too much. So I heard Gary's already in CAD track. Then we can have Gary's before this, then Ben, we can contact for the plugin, maybe in another track too. Or if not, then we will just add this to the end of a panel discussion drawing here.
Okay. So now we'll begin the next part.
So for we are doing the tracks. Actually, how can we have a CAD track? Audrey, did you post the CAD track URL, Zoom?
Okay, so I just sent the Zoom link out into the chat. I'm not sure how Gary got there before because I didn't start the meeting beforehand or anything.
Okay, let's just go ahead. For people who want to continue to CAD track, you can go to the Zoom link in the chat window. And for the panel discussion, you can continue in this main session.